Hello everyone, welcome to my YouTube channel. Let's learn. So, if you like this kind of video which I will try to explain, so please like, comment, and subscribe my channel if you really like what I am about to explain in this video. So, in this video, as you have seen in the title itself, I will talk about projectile motions. So what are projectile motions? Projectile motions are the motion of an object which is under some external force. So for example, when an object is thrown on the earth's surface, the effect of gravity, that is the change in the path of an object with the gravity, is a projectile motion. So when you throw an object up in the sky, it falls down like this. So instead of going in the dotted path, it falls down. It is because gravity is acting perpendicular everywhere throughout the path of an object. So this path, this nature of an object when it is thrown in a direction in the presence of gravity is known as the projectile motion. A projectile motion can be normal horizontal projectile motion and vertical projectile motion. So you are throwing something above the sky at some angle. So basically if you throw straight up in the sky, it will fall down. But if you throw something at some angle which is not 90 degree, then it will fall down. And if theta is 0, that is you are standing at the top of a building and you throw something, so it will fall down. So this is horizontal projectile. Now, why are we studying these projectiles? Why are we studying these projectiles? So, firstly, let me tell you something. Suppose you are standing at the top of a mountain and there is some object at the top of, say, some kind of tower which is a little bit far away. Now, how do you suppose you have to throw a ball such that it hits that object? How would you do that? So you can control the angle and you have the initial velocity. So how can you reach the final destination? So this is a practical problem. So you need to calculate, you need to find some kind of formula, you need to find some theory which will give the result so that at some particular angle, at a given velocity, it will reach that point. So if we throw it with full energy, it may move some other path and it will not reach where it is destined to go. So projectile motion is very important to understand the physics, to understand the nature of how object behaves under gravity. So let us jump into the basic projectile motion. Let us go through the calculation. How easily can we solve? So first I will just draw a coordinate where x is the horizontal separation, that is, suppose say it is just a hill, sun. So this distance, that is the path along the ground, that is x, and the height is given by y. Okay, so y is the height. So when you throw, let the origin be the point where you throw an object up in the sky. So the projectile motion, it will go up. Suppose you throw a stone, so it goes up and then falls down. Okay, so we are interested to know what is the nature of this graph. Is it a part of a circle? Is it a parabola? What is it? And what is the maximum height of the projectile? What is the range of the projectile? What's the time taken for the projectile to hit the ground? These are the questions we are going to be addressed. Okay, fine. So let's go through the calculation. The calculation is very easy, let me tell you. But I'll just show you how you will do this kind of problem. So I have this projectile. I will draw that once again. And let you throw a stone up. Let me first consider that you are assuming that you are throwing a stone up in the sky at some angle theta, and the initial velocity of the stone is u. Fine. Using this analogy, I will try to solve how you will approach to solve the range, time taken, the maximum height, how much distance the stone will travel, okay, and so on. So any velocity, suppose there is a particle is moving in some zigzag curve, the velocity can be divided into two components, ux and uy. Similarly, the velocity at this point can be divided into ux and uy. Fine. So ux will be u cos theta. Fine. And uy will be u sin theta. Okay, because this angle is theta. Now ux is along the x direction, so gravity is 90 degree to ux. So ux will not change due to gravity. That is, ux will be constant. So ux, which was equal to u cos theta, is constant, and it is constant for large t. That is, even if time tends to infinity, ux will be constant. Now uy is parallel to g. So uy will decrease with g. Fine. Let at a particular time the velocity along y is u prime. So u prime will be u sin theta minus gt. Okay. So the vertical velocity, if you plot the vertical velocity with time, so at t equal to 0 it is u sin theta, and it is a linear graph, so the vertical velocity as a function of time will look like this. Okay, so I have this projectile motion. So what is the maximum height? Note that the maximum height is at this point. At this point, the velocity along y should be 0 because it is not moving upward, right? It is just sliding down along the horizontal line. So uy should be 0. To make uy 0, we have t equal to u sin theta by g. So we have t equal to u sin theta by g. Now this is t. Okay, the time taken to reach the maximum height is t, and after that it will again fall down, and it will fall down at the same time. Assume I actually did not assume the wind speed, the air friction and all those things. This is just an ideal case. So the time taken to move up will be equal to the time taken to fall down. It will be exactly equal. So the total time for the projectile will be 2 times the small t, that is 2u sin theta by g. So this is the total time taken by the projectile motion. Fine. Okay. Now let us find the maximum range of the projectile. Now we know the time taken for the projectile, and we know that the range is dependent on the horizontal component of the velocity, that is ux, because uy will not contribute to the range. Uy points upward. Only ux, that is the horizontal velocity, will contribute to the range. So range will be time times ux. It is equal to 2u sin theta by g times u cos theta. So it will be u square sin 2 theta by g. That is the maximum range of the projectile. That is the maximum distance the stone will travel before hitting the ground, or at the point where it hits the ground. That is the maximum range. So let us find the maximum height of the projectile. So at maximum height, uy is 0. So we know that at t equal to u sin theta by g, uy is 0. Okay. Then the maximum height will be given by the equation of motion. You know that v square minus u square equal to 2as. So the final velocity is 0. So that is minus u square equal to 2gh. Now minus sign I have introduced because the acceleration is downwards. Okay. So h is u square by 2g, or h is u sin square theta by 2g, because u is u. Here u is u sin theta, right? Because this is actually u sin theta. This is u sin theta, because we are considering only the vertical part of the motion. We are considering in uy, and uy was u sin theta. Okay. So the maximum height is this, and the range was u square sin 2 theta by g, and the time taken was 2u cos theta by g. Let me confirm that one once again. I did not actually remember. No, it actually was sin theta. Okay, fine. So these three formulas are the most important formula in projectile motion. You have to remember all this. So I myself don't remember this formula. You just derive. Okay, these three formulas. First of all, what is the maximum range of a projectile? Now the maximum range of a projectile is when sin 2 theta is 1. Sin 2 theta is 1 when 2 theta is equal to pi by 2. So range maximum at theta equal to pi by 4. Let me tell you one more thing. Suppose I have a projectile motion. So at point A, that is at this point, the potential energy is 0 and the kinetic energy is maximum. As you go higher, the speed decreases, and at this point, the potential energy at point B, the potential energy is maximum, and the kinetic energy is 0, and after that it changes. The kinetic energy increases, the potential energy becomes 0 at point C. So these are the things you need to consider. Okay, and one more thing I would like to tell you, that is the height. So you know that S equal to ut plus half gt square. So here S is h, so that is height. So u is u sine theta, and t is u sine theta by g 2u. Okay, minus half g t square is u square for sine square theta by g square. Okay, and x is u cos theta t. So we can simplify to write h is equal to u sine theta t minus half gt square, which is equal to x tan theta minus g x square by 2u square cos square theta. You can just solve and try to check that you are getting this value. So h is actually y, that is the height. So I've drawn x and y. So y is the height, which is I've denoted by h. So y is in this form, x minus bx square. So what is this? Can you recall? This is a parabola. So in many exams and many competitive exams, it is asked that suppose you have a projectile motion and a constant acceleration is acting downward. So what is the path? What is the nature of the path? So the nature of the path is parabolic. It will always be parabolic if we have a constant acceleration. Now if the acceleration is a function of time or something like that, or a function of distance, then you need to solve this problem, this equation, and then substitute the values and try to see how y is dependent on x, and that will determine the nature of the curve. So in short, the projectile motion is parabolic in nature. So this is not a part of a circle, but this is a parabola. Fine. Similarly, in horizontal projectile also, we consider ui to be 0, and there will only be ux initially, and later ui will increase, and finally ux will be 0 at this point, because it will just fall down. Okay, and then you try to calculate the things, that the time taken to fall this height h in horizontal projectile. So you know that v square minus u square is 2s, something like that. So u square is 2gh. So maximum height will be u square by 2g. Okay, so you can find the formula. Also you can use s equal to ut plus half at square. So if the initial velocity is 0, then t is equal to 2s by a, here is g. So the time taken, so if I have a horizontal projectile, the time taken to fall this height h, t, if the height is s, so t will be given by 2s by g, and use this time similarly to find the maximum range, just writing u cos theta, u sin theta, and so on. The height you already know s, and the range will be found, and the t you know. So this kind of things can be calculated from projectile motion. So let me just give you another example about this projectile motion. So even in, when you suppose you are standing in front of a building. Okay, you're standing here and you are asked to throw something to the highest floor possible. So at what angle would you throw this object? So it depends, and there is a maximum velocity with which you can throw anything. Suppose you are throwing from this point towards a wall. If your velocity is constant, if your angle is very less, then it will just go to this path. Okay, if you increase the angle to 45 degree, it will hit somewhere like this. If you increase the angle further, it will just go up and then fall down, and further it will even not reach the building, it will just fall below. So note that we have already shown that the range is maximum at theta equal to pi by 4. So when the theta is pi by 4, the range is maximum, so there is a high chance that it will hit at a higher floor in the building. So these kind of things can be done. You can see the projectile motion is very much related to physical phenomena. And okay, so I will not speak more about this topic. This is quite easy. So thank you for watching. I think you like this video. I don't know actually. So please leave a comment if you like this video, if you find this useful, if you like the way I explained this video. So just drop a like, comment, subscribe, whatever you feel. Actually, I'm new to this channel and I'm improving. So you can just provide some suggestions and also share this video to your friends if they want to know something about it. Okay, so thank you, take care.